introduction and the opportunity to participate today. I am a rocket scientist with the missiles and space group here, but I've been working in the energy field with Lockheed Martin across the corporation. We've got strong association with a number of federal research labs, academic institutions, and key national customers as they look at this problem. And a lot of people ask us, at Space Systems Company, what do you know about ecosystems and energy? And it's a pretty simple punchline. We've been building satellites since the 60s, and so when a satellite leaves the ground, it goes off the grid from its energy consumption power net. And since the 70s, we've been keeping people alive in space off the grid. So if you think about microgrids or mini microgrids or many small microgrids, we've been practicing this science for quite a while. So that's kind of the segue from space. The work that we've been focusing on smart grids really emphasizes the grid security issues. And the cover slide here shows a contrast of the U.S. grid, and taken from space, one of our satellites. The larger picture is what the U.S. looks like at night. And in 2003, there was an eastern seaboard outage, which was brought about by a natural event, but it created a cascading of power outages. And so if you want to think about smart grids and a national security resiliency, take a look at that footprint that is black in that picture and ask yourself about the continuity of government and the provision for kind of human services for a number of hours. So our motivations and interests are to kind of address what issues bring those things about. As Rex alluded, we have been working across the spectrum of energy. In energy efficiency, we have acquired a corporation called Aspen, and we are one of the largest energy efficiency audit organizations. We have won contracts with the Department of Defense, Department of Energy, and the GSA to audit the federal facilities for energy concerns. And the federal government is putting policies out to try to get more energy efficient in their facilities. Now, we're not doing the physical A&E work on those facilities, but we're helping do the audits and identify where to make the changes. In terms of alternative power generation across the front at our variety of facilities, from Eagan, Minnesota to Florida, to Boulder, outside Boulder, to Arizona, we're working with all of these. We do have a partnership with China on nuclear controls. We have been working in nuclear facility management and in small nuclear systems for propulsion. And recently won a decent-sized job on BOOTech. And we've been working in the ocean thermal since the 1970s. Wind power, we have an organization north of Louisville, Colorado, called Coherent Technologies. We're using laser LiDAR to kind of track wind vortex. We were doing that for the FAA to kind of perfect how airplanes landed at airports, and the derivative piece of knowledge was we were able to predict load management on wind farms. And so we now are able to kind of help the production output and capacity in those locations. In terms of energy management and storage, I'm going to talk a little bit about the storage challenge. And yesterday, while we were on kind of a run-up call, Frank, I think you mentioned you had some storage footstops that you wanted to make as well. Our Department of Defense customer really is looking at energy management and storage on an emphasis of microgrids. Each of these large DoD facilities here is taking a look at its energy vulnerabilities, and they're looking at strategies and technologies to kind of isolate them from vulnerabilities. So think about this regionally. If you're at Fort Carson down there, there's a large opportunity. If you're at F.E. Warren Air Force Base in Wyoming, there's a lot of real estate there for which to produce your own power. Storage technology, the general conclusion on the grid is power is available, but it's usually available in the wrong place at the wrong time, and so there's a matching principle. And the last piece, and it all ties together with climate monitoring and carbon mitigation. Coal production likely will stay a U.S. standard, and we're going to have to deal with the means to keep coal clean or deal with clean coal here in the U.S. So carbon sequestration is going to be a topic for us. And one of the things that we've been able to do, again, afoot for space programs, is when we go to other locations, the moon, Mars, we have perfected in situ propellant manufacturing, which we're able to mine on the surface of planets and convert. And that technology in practice, by the means of certain types of reactors, we're able to do some carbon sequestration techniques. I would talk about global warming today, but that's not necessary. The grid evolution, the story for us starts, how did we get here? It basically is putting together a large-scale network. If you step back and look at it, there was no forethought and no design to what we have. It was basically drive out, build some more, drive out, build some more, add some capacity, replace some capacity, modernize. There was no pre-planned scheme. And so what that says is across the country, you have about 5,500 power plants, you have a range of consumers, industrial, and you have aging infrastructure associated with new production. And so if you step back, the first thing that needs to be done smart grid-wise is a systems engineering architecture of what exists. Design 50 years ago, design is being kind. I think maybe with the advent of some cameras, people started taking pictures of what existed, and we call that its basic design. But it was individual and discrete projects put together and linked, and I don't think that there was anybody then that was thinking about how the future evolution of this would occur. And a number of those projects put in the 50s and 60s and 70s were not architected to be sustained or evolved. Certainly not with today's technology. In terms of grid evolution, the characteristic predominantly, and I'm going to get to the technology piece in a second, first and foremost is to generate consumer participation in the grid evolution. Today, with that national grid, we operate at about a 55% asset utilization, and so there's peaks and valleys in terms of when demand and supply mismatch. And the first thing to do is to get knowledge of how consumers are behaving and to model that behavior and figure out where we can start to match that up. We need to accommodate all forms of generation and storage, and a number of the renewable generation techniques are somewhat remote from the communities that consume it. So transportation and distribution is going to be a challenge. And then there needs to be an optimization.